So here we're told about a transmission line that consists of aluminium and steel wires. So there are 6 aluminium wires and a steel cable in the middle. Each of these is circular, and they give us information about the length of these cables, 1 kilometer. So you need to multiply that by 10 to the power 3 to convert to meters. You're given the resistance of the steel and the resistance of the aluminium. You're given the diameter, and it says of the steel wire. I'm guessing they'll all have the same diameter. They haven't said so, but we can probably show that these all have the same diameter. Now, diameter is that distance there, and that is, by definition, twice the radius. So the radius is half the diameter. And we're going to need the area, the cross-sectional area of one of these cables. And because it's a circle, it's simply the area of a circle, which is pi times r squared. Okay, so if we get back to the question, it's asking for the resistivity, and it's the steel that they're asking for. So resistivity is this symbol here, rho. So rho is, it looks like a P, and it's actually resistivity, and the units is in ohm meters. So from the formula sheet, resistivity is R multiplied by A divided by L. Right, so we know R because R is the resistance of steel, 3.3. We know L because L is the length, which is 1 kilometer. And if you multiply that by 10 to the power 3, that will give it to you in meters. What we don't know is A, but as I said, we can find it by calculating pi r squared. And r is half of d, and because d is given in millimeters, we need to multiply times 10 to the minus 3 to convert it to meters. So that's our diameter. Divide by 2, that gives you radius. And then if you square the radius and multiply it by pi, let me just write it out again, A equals pi r squared. Now, this equation you're not given in the exam, but I expect you know this. Or you're expected to know this. So that'll give you your area in meters squared. And now you know that, you simply plug these numbers in. So that goes into there, and the 3.3 goes into the resistance, and this 1000 goes into L. You put that in your calculator. This will be the final answer for resistivity, and the unit is ohm meter. Ohm meter. So that's your resistivity for the steel. They didn't ask for the resistivity of the aluminium. So that's your final answer for part A. Calculate the resistivity of steel, state an appropriate units. We've done that. Right. It's now asking for an explanation why only a small percentage of the total current goes through the steel wire. So remember, we have steel and we have aluminium. So steel, in terms of area, is 1/7. Right? So the area of steel divided by area total is 1 over 6 plus 1, so it's 1/7 of the total in terms of the area. But the actual resistance is higher. So the higher the resistance, the lower the current. So current is inversely proportional to resistance because that's in the denominator. So if this increases, this decreases. And we have 6 aluminium wires for 1 steel, and the resistance of the steel wire is 3 times that of the aluminium. So the total resistance of the aluminium will be 6 times 1.1, because each of the aluminium wires is 1.1. So 6 multiplied by 1.1 is 6.6 ohms. That's the aluminium. The resistance of the steel is 3.3. So the percentage current that passes through the steel, so the total resistance is, let's just write, total resistance is 6.6 plus 3.3, which is 9.9. Okay, so that's the resistance in total. The resistance of the steel is 3.3. So if you divide 3.3 of this over that, you get 30%. So that's 30% of the current. So that explains why such a small percentage of the current, it's saying explain why only a small percentage of the current passes through the steel wire. So there's 2 reasons. There's more aluminium than steel, and the resistance of the steel is considerably higher. Although I'm not sure if that's entirely accurate.